So let us start with the design problem. I am Dr. Srikant Halle and going to explain you about the design problem of a water tank with the help of working stress method. So we'll write down a problem first of all. So the problem is design a circular water tank with flexible base with flexible base for capacity of 5 lakh liters. So that is the problem. Design a circular water tank with flexible base for capacity of 5 lakh liters. Now we'll go ahead with the solution. First of all, you need to understand what exactly is given. So the given part is, it is a circular water tank we need to design. Then the flexible base it is given, and then capacity is given, that is 5 lakh liters. Okay. So now certain things we need to assume. So first of all, let us assume the depth of 4 meter. So we can just write down depth of 4 meter is provided and we need to give the freeboard. So let us take with freeboard of 0.2 meter. Freeboard of 0.2 meter. Now let us consider if the depth which is we have considered or assumed as 4 meter. Now let us assume that D is the diameter of the tank. So we can just write down D is the diameter of the water tank. So we can simply calculate the capacity of the tank. So therefore capacity of the tank would be equals to. Now before going further, you need to understand what are the design different steps we are going through. So the first of all we'll be just going through the calculation of the capacity, and from that we can just calculate diameter of the tank. Once we got the diameter of the tank, then we can just calculate maximum hoop tension, which is going to be the important parameter in case of the wall of the water tank, and accordingly we will calculate what is the area of steel required, and we'll just provide the number of bars on the wall of the water tank. And once you provide that, we can calculate the hoop reinforcement for the different height as well. And similarly, we can calculate the vertical reinforcement in the wall. And then once we calculate the vertical reinforcement, then we can go ahead with the design of the raft or the base slab. And then finally the reinforcement details. So this is how the design steps would be there. So capacity of the tank, let us consider this as your step number 1, in which you are going to calculate the diameter. Okay. So capacity would be just simply the formula volume equals to area into H, right? So volume will be equals to area into H. So we have this volume is equal to, you have this area multiplied by height. Volume is already given. Volume means you have the capacity is already given. That is 5 lakh liters. So we can just simply write down, that is 5 lakhs liter, and area it is given, since it is a circular, so pi by 4 into, we have a d square multiplied by, let us consider here h1 is the height. Now here you need to understand one liter equals to 10 raised to power 3 meter cube. Okay, so we have here 5 lakh liters now. So 5 lakh liters is given. So what we can do in terms of, if you want, in terms of meter cube, okay, so we can just simply make it as 1 by 10 raised to power 3. That will be converting in terms of the meter cube. And H1, here H1 would be, if you just calculate the capital H minus H dash. Here capital H, it is 4 meter, that is the depth we have assumed, and let us consider freeboard, and this will give you 3.8 meter. So once we go with the calculation of very easy way with the help of, we just need to convert liter into meter cube, and once we convert that, we can just simply put it into the step number 1. Now you need to understand here h1, which is actually the height, and height of the water here it is to be assumed, and total height or total depth is 4 meter minus, if we just deduct the freeboard height, so that is say 0.2 meters. So 4 minus 0.2, you will get 3.8 meter. Now once you got that, we can here put, or we can get d equals to, if we calculate, now we need to round it up, so this will come around 13 meter. 13 meter, and you need to provide, you can write down here that therefore provide diameter of 13 meter. So this is how you need to just go ahead with the step number 1, where here we have calculated. First of all, what exactly the diameter of the water tank is. Basically, the design problem is design a circular water tank with flexible base for capacity of 5 lakh liters, and depth of 4 meter we can assume, and freeboard also we can assume here 0.2 meter, and then capacity for is already given. So with the help of formula of volume equals to area into depth or height, so from there we can easily get what is the diameter required. And you need to understand that is 1 liter equals to 10 raised to the power 3 meter cube, and accordingly if you want to convert into meter cube, you need to just divide it by 1 by 10 raised to the power 3. So here we got around diameter of 13 meter, and the step number 2, which is of here you need to calculate area of the steel required in case of hoop tension. So area of the hoop tension we need to calculate, and before that we can just calculate what is the maximum hoop tension. So you know that the maximum hoop tension would be at the base. So you can simply write down maximum hoop tension at base, which is the maximum, and we need to consider for only 1 meter height. For 1 meter height. and this is equals to, we have gone through the earlier videos in which we have seen what is the maximum hook tension. So maximum hook tension is going to be WH into D by 2. So WH into D by 2 is for the maximum hook tension. W, it is the 9.81. H we know that is 4, and D we have calculated 13. So this is how we will get. If we just calculate here this value, 9.81 into 4 into 13 by 2. So here we will get maximum hook tension, which is going to be at the base, and we are considering here circular water tank. Okay, so for circular water tank we will be getting this value of 260 kilonewton. 260 kilonewton. So this is the maximum hook tension, and for that we need to calculate what is the area of steel required. So we will just write down area of steel required. Now this is equals to maximum hook tension. You can just write down here T is your maximum, T max you can write down. So area of steel required would be equals to, this is we need to calculate. So you know the stress, which is equals to force divided by area. That is the formula. Force equals to, we'll get stress into areas, or you can get area equals to force divided by. So you can write down here T max is equal divided by sigma. Now in earlier videos we have gone through what exactly the sigma should be taken, or the permissible stresses should be taken. So your permissible stress to be taken in case of the water tank is specifically a circular water tank. Okay. So here T max, as we know that the stress is equal to force divided by area, and this is how we will get the area equals to this force divided by stress. So T max is equals to 260. We'll just convert it into in terms of Newton. So this is 10 to the power 3. So here you can write down here Newton, this is the unit, and this is sigma, it is 100 Newton per mm square. So therefore finally you will get ASH, area of the steel required, and this is equals to 2600 mm square. 2600 mm square is the area of the steel required. Okay. Now if we just talk about or we can write down providing 16 mm diameter of bars. Okay, so if we just provide 16 mm diameter of the bar, so you need to simply calculate spacing. So spacing you can calculate for 1 meter. Okay. So therefore you need to calculate the spacing of this. Okay. So if we just calculate the spacing, that is going to be around, in terms of the total area and area of 1 bar, and in terms of 1 meter height. So this is coming out to be 70 mm, and you can provide this 16 mm diameter bar at the rate spacing of 70 mm.